Good morning, good afternoon, everyone. My name is Raman Sridharan. I'm with Data Physics. Thanks for joining today's webinar entitled From Profile Setup to Report Streamlined Shaker Testing with the 900 Series Controller. And today's agenda is a live demo of the SignalCalc 900 Series software. I have a test profile from a customer that I'm going to enter into the software, run on my shaker, and then the second section of the agenda is going to be generating a report from all of the data that I collected. So you'll see as I show you the test specification, but it includes a pre-test sine sweep, a random vibe test, and a post-test sine sweep, which is a common pattern in vibration testing. You identify your resonances before you start a test, you run the test, and then you see if your resonances have shifted. So with that, I'm going to get to the live demo. And I'm going to start by showing you the vibration test specification. So this test specification is sent to me by a company called Complex Microstructures, and the test article is called a flex beam. So as you can see, the test specification, as I mentioned, is 3 sections. The first section is a pre-test sine sweep verification. So we mount the test article on the shaker, and it's subjected to the following sine sweep profile from 5 Hz to 1000 Hz, starting at 0.05 inches peak to peak displacement and transitioning to 1/4 of a G all the way out to 1000 Hz. The test is going to run at 3 octaves a minute for a total test time of 2 minutes, 52 seconds. And 2 control accelerometers are placed on either end of the beam and averaged. And 2 other accelerometers are going to be used as response measurements in the middle of the test article. And the spec states that I need to identify resonant frequencies and resonant peaks and place those results in the report. So just to show you how my shaker and test article are mounted right now, I have a camera view of my shaker. So this is the beam going across the shaker, and I have 2 accelerometers on either end that are going to be the control accelerometers, and the 2 in the middle that are going to be the measurement channels. Okay, so after the initial sine sweep, I'm going to be running a random vibration test, a uniform random profile for 2 minutes. The overall GRMS is 0.25 GRMS, with the peaks occurring at 3 times the RMS, with a bandwidth of 20 to 2000 Hertz. And the accelerometer configuration is the same as the sine sweep. And the final part of this spec is to run a post random vibe sine sweep and with the same exact configuration as the first, and identify the resonances, resonant frequencies, and peaks. All right, so with that, I'm going to jump into the SignalCalc 900 software and start executing this profile. So for those of you who are not familiar with the SignalCalc 900 software suite, I'll give just a really brief overview here. We have the software is broken up into 4 different sections. The first section is managed tests. And the managed test screen is a database of every test I've ever created. And if I expand any of my tests, you can see every time I've run that test. It's also fully searchable, so I can type in any keywords here or any of the metadata, customer names, test names, and it'll search through all of my tests and runs. So I can easily find any test setups that I've created in the past. So I'm going to create a new test now. I'm going to go to new, and starting out with a sine vibration test. So the actual setting up of a test to go from that test spec that we gave here, that I have here, the first sine sweep with the breakpoint frequencies and this accelerometer configuration, I'm going to enter that into our software now. So for the test name, this first tab here, the test setup is broken into 3 different tabs. The first tab here is the test tab, and this is all just notation and bookkeeping. And it's important to be detailed here because all the parameters you use here you can bring up on your plots or in your reports. So for the test name, it's going to be sine sweep verification. For my customer, complex microstructures, and the test article is the flex beam. Test description, I'm going to enter a brief description of this test. It's 5 to 1000 hertz, 0.05 inch displacement. This transition to 0.25 G peak. Okay, and then down here, the bottom section, run notes. I'm going to add 2 run notes, and what run notes are just prompts that it'll ask me every time I run this profile. It's going to ask me who's the operator and what axis of vibration am I testing, and then it'll save that as metadata with the test. Okay, moving over to the channels tab here. I'm going to quickly come back to my video here. And I'm going to remove my background so you can actually see the vibe controller in the background. So I've got the 4 accelerometers here that are connected, if you can see back here, to my 906 controller, to the top 4 BNC connectors, the top 4 in a square. My controller is connected into the amplifier, which is driving the shaker. And just for clarity, I'm going to add this background back so that it picture isn't so cluttered. Okay, so with that channel configuration, I'm going to come in and select my input channels. I have the top 4 square of accelerometers selected and select OK. Then I'm going to hide all of my unselected input channels, so I only see these channels 1, 2, 7, and 8. And then I'm going to configure channel 1 and channel 8 as my control channels, which are the left and right control. I'm going to give each channel a name. That'll be useful because these will display in the legends when I display my plots. Left, center, right, center, and right. And then I'm going to set up my accelerometer settings. Now, instead of entering in my millivolts per G sensitivity, my accelerometers support the TEDs. They have a TEDS chip on there which stores their sensitivity electronically, so I can just set the sensor class to TEDS, and it loads the sensitivities right off the sensors themselves. Down in the bottom of the screen, the output channel, which is connected to the shaker. I'm going to select my shaker from my pull-down list. I've only got 1 shaker in this list, the GW-V4, which is this small desktop shaker I'm using. And then I'm going to enter the mass of the flex beam, which is 0.25 pounds, and say, OK, so the controller keeps track of how much mass you've got on your shaker table. All right, with that, I'm going to head into the 3rd tab of the setup, which is the sine measurement tab. So the sine tab starts out with the reference profile. So the reference profile is that we saw from the test spec, 5 hertz, 0.05 inch peak-to-peak displacement. And then at 9.89 hertz, it transitions to 0.25 G peak. So I'm going to enter that 5 hertz, 0.05 inch CD for constant displacement. That's in inches. For my transition frequency, I'm going to write 0. The software will automatically calculate where 0.05 inches intersects with 0.25 G. So for 0.05, I have CD for constant displacement in inches. For 0.25, I have CA for constant acceleration in Gs. And hit apply. And you can see it calculated that 9.89 hertz transition point, and I have a smooth transition from 0.05 inch to 1/4 of a G peak. You can see here on the right side, it tells me how close I am to my acceleration, velocity, displacement limits of the shaker given my test article mass. And you can see I'm well within my limits of my shaker here. The second tab for the sine setup is the control parameters. I'm going to leave this autofill from reference box checked. That fills in a lot of my parameters automatically. For my sweep rate, the spec calls out 3 octave per minute. And I'm going to leave my sensitivity, control sensitivity values as the default. That typically works out. And I know I've got a very dynamic test article, so I'm going to decrease my minimum level a bit to allow for the control signal on one of the 2 controlled cells to drop due to anti-resonances, which I know I'm going to have in this, given the flexibility and dynamics of this test article. So I'm using average control, my octave per minute sweep rate, 3 octaves per minute. And then I have my sine filter settings that I'm going to leave up as default here, which typically works for most sine tests. Now, if you have familiarity with running on these small V4 shakers or any small shaker in general, you know that running down to 5 hertz can be tricky. And in other controllers and in older versions of the data physics controllers, you had to come in and tweak some of the pre-test parameters to get that to work. One of the new exciting features we have in this current version of our software I'm demoing now, that's available to all of our customers now, is this auto shape broadband functionality. That's a algorithm which goes through and automatically tweaks the pretest as it's running as needed to make sure you get a good quality pretest and to make sure the test starts out well. So I'm going to leave all my pretest settings default, even though I have a 5 hertz start frequency, which is typically a tough thing to start at, tough place to start. The signals tab of the setup, this shows you which signals are going to be displayed or available to me during the test. If I want to export, say, to ASCII file or MATLAB, I can set up exports down here. I'm going to leave that blank because I don't need to have that done during this test. And the final tab, my schedule, my run schedule. If I wanted to add dwells or partial sweeps or sequence 10 sweeps in a row, I could do that here. In this case, I'm just going to be running 1 sweep with the initial direction up, meaning starting from 5 hertz and going up. Okay, I'm going to hit run. And that's going to prompt me for my profile name, sine sweep verification. I hit OK, and now I'm ready to run my test. So before I run my test, I want to talk about one of the new functionalities that was recently added to our software in the last couple of weeks here, and that's the concept of attachments. So our software now has the ability to save attachments, which are intended to be things like images, right into your test database. So we already store all of your test data and run data along with, in the manage test screen. Now we allow you to add attachments, which can be any digital file, but the intention is to use it for mostly for images. So you can add attachments that get saved along in your test database. So it's going to stay there. If I review the test now, I'll be able to print my images into my report. If I review the test 6 months from now, I can still print my images in my report. They're going to be saved along in your test database. So I opened the attachments window for this test. So you can see the attachments related to this sine sweep verification test. And the first thing I'm going to do is I'm going to say attach. And I have taken a screenshot of the profile previously. I just took a little snippet screenshot of the actual breakpoint table and profile, and I'm going to attach that to the test. And as a description, I'm going to call this the profile provided by customer. This is not only good for our own records, that we have a record of the actual profile saved along with the test data, but I can also print this out in the report. So the report will start out with this profile, and you can, so the report tells a story. It tells you this is the profile is provided, and then here's the data that proves that I executed this profile successfully. All right, the second thing I'm going to do is I'm going to attach a photo of the test article mounted on the shaker. So I'm going to click on Take Photo over here in the corner. Let me make this a little bit bigger. And the software connects directly up to the camera, the live camera I have. So here is the test article mounted on the shaker. Click Capture and Save. So the description of this photo I'm going to say is test article or test for sine sweep. All right, so I have 2 attachments saved to this test. I'm going to hit close, and now I'm ready to start my test. So I'm going to click initialize, and I'm going to be very thorough with my documentation because this all helps me generate reports quickly and easily. And again, all this documentation is searchable. So run name, initial sweep, or resonance. I'll just call this initial sweep. And from the run description, I'll write initial sweep for resonance identification. The operator, the run notes I asked for, operator, I'm going to enter my initials, and axis, the z-axis. All right, it's going to ask me to verify that my stop switch is connected. So I'm going to hit the stop button to acknowledge that it's connected in case of emergencies. During the test, I can use that. The software knows that the stop switch is there. And I'm going to hit start. So before I hit start, the one thing I didn't do as part of this test setup procedure is to set up my plots. So I'm going to hit start, run the pretest, and while the actual test is executing, I'm going to set up my plots to set them up as I want them to be in my report. So I'll hit start. I'm going to run my pretest. So if you look here in the pretest, it says shaping drive. That's the auto shape pretest algorithm working, and that guarantees me, that ensures that I get good quality pretest data. And if you're familiar with coherence function, you could see this middle plot here. My control channel coherence is pretty high at 5 Hertz, considering I'm only driving with a 10 millivolt drive signal. So this pretest data looks good. The auto shape pretest worked well. My pretest report has come up, and it's predicting 0.25, 0.24 volts of drive signal required to run this profile. I'm going to hit start. And you can see the software flips me over from my pretest tab to my control drive tab. So these tabs are different arrangements of plots on the screen. You can add more plots. I can click on new page, that'll add a new tab, or I can always modify the tabs that I have here already. So just to show you a live view of the shaker, you can see the shaker is executing this test as as we see on the screen. But now, while the test is running, I'm actually going to configure my plots. In the interest of time, I don't want to do typically I would do this before the test, but in the interest of time here, since I'm trying to keep this to 1 hour, I'm going to configure my plots as I want to see them in my report. So if I right-click on the plot and go to Graph Attributes, I can configure pretty much every single detail of the plots, the titles, the colors, the annotations, any test parameters I want to display on them. But I've already done that before this, and I saved my plot configuration as a graph template. So I'm just going to right-click on my plot and say Apply Graph Template, and I can select my sine control template. And boom, my plot is now configured as I want it. So these graph templates you can save them across multiple tests. If I create a new sine test tomorrow, I can use that same template. They're there to do exactly as I did, so that setting up my plots is actually very quick and easy instead of having to do it every time. So right-click on the second plot, Apply Graph Template, and I have one saved for my drive signal. And now I'm going to create a new plot to show my transmissibility, to identify my resonances as the test spec called out. So I'm going to right-click on any graph and click on New Graph, which is going to add a new graph at the bottom. and right-click on that new graph and select Add Signals. The signal I want is transmissibility at the very bottom, and the spec mentioned any one of my control signals has to be my reference channel. So I'm going to select channel 1 to be my reference channel and generate a transmissibility signal between each of my other response channels and channel 1. So select channel 2, channel 7 and channel 1, and channel 8 and channel 1. Okay, so there's my transmissibility plot. Again, apply graph template, and I'm going to select sine transmissibility, and there it is. So I'm going to retile my plots into a different arrangement so that it looks a little nicer. And there I have them. So my test is already finished by the time I set up these plots. What I'm going to do here before I click end is I'm going to go back to my attachments and add one more photo of my test article after the test is complete. So in case, the test article broke or, something, an accelerometer flew up or a screw came off, you can have photo documentation saved along with the test. In this case, the photo documentation shows that the test article seems to have survived. Test article after sine sweep. All right, so close, and now I'm going to hit end. So now my initial sine sweep is completed, and it's going to pop my sine sweep over into review mode where I could create the report. But just for the purposes of this presentation, I'm going to actually finish executing my full test spec, the sine, the random, and the third sine, and then generate all my reports at the very end. So the next portion of the test spec is the random test. So I'm going to go back to Manage Tests and create a new random test. All right, so this random test is set up just like the sine test. The first test tab is just for notation. So I'm going to call this operational. Oh, you can see I've entered this title before, operational random vibe as the test title. Customer, complex microstructures, test article, flex beam. Test description, it's a 0.25 GRMS, 20 to 2000 hertz random flat random profile. All right, run notes. Again, I'm going to add the same run notes, operator, and axis. My channel configuration, I'm going to, instead of re-entering all my channels, I'm going to go to import channel table from database, and that lets me select my sine sweep test, and it imports all my channel names from there. I just have to select which channels I want and which ones are the controls. And I can hide all my other channels again. And there's my channel setup again. The channel setup also loaded my shaker configuration and my 0.25 pound mass. So that's all saved along with the channel configuration. All right, my random profile. So the breakpoint table is a standard breakpoint table, but this particular profile is very simple. A flat 0.25 GRMS profile from 20 to 2000 hertz. So I'm going to remove the first and the last line and just enter 20 hertz to 2000 hertz. And I'm going to just leave the same value entered for ref. It doesn't matter what I enter for the reference because I hit apply. You can see it's flat. And I'm just going to come over here to the rescale and add a rescale RMS to 0.25 and hit apply. So now it dropped down these breakpoints down so that the whole profile is 0.25 GRMS. You can see my peaks are already configured to be 3 sigma. The peaks are 3 times that RMS. 3 sigma, and my shaker is well within its tolerance limits. My control parameters, again, I'm going to use the autofill from reference to have the software fill in most of my test parameters. My 3 sigma clipping and average control on the 2 control channels. I'm going to use my auto shape broadband pretest, which will automatically run the pretest, tweak the pretest to make sure I get a good starting FRF and that the test starts successfully. The signals, I'm going to, I don't need any signal exports, so I'm just going to bypass the signals tab. And now in my run schedule, I'm going to let it ramp up starting out at minus 12 dB for 10 seconds, then bump my way up 10 seconds for every 3 dB. And we want 2 minutes for the full runtime as per the profile. 120 seconds is 2 minutes. Okay, and the reason we bump up the test level like this is, we don't want to jump straight into the profile. Giving the controller time at lower levels gives the controller time to adapt and adjust to any of the changes in the test article, and make sure the control is good by the time you get to the full 0 dB test. Okay, I'm going to hit run and run my random test. It's going to open up in the run test screen, which is where, as you saw in the sine test, this is where we're viewing live data and viewing any test that's currently executing. So just like the sine test, I'm going to go to attachments first. And you can see my attachments for my sine test are now gone because these are attachments specific to the operational random vibe test. So I'm going to hit attach, and I'm going to attach the photo that I took, the snip photo snippet that I took of the random vibe profile. As description, I'm going to enter profile provided by customer. And then I'm going to also take a photo of the test article before the test. So capture and save. Test article before vibe. Okay. And then similar to the sine test, I'm going to hit initialize. Operational word random here, vibe, and the run description is operational random vibration. All right, operator and axis. All right. So we're ready to start. Confirm my stop switch is connected. And my pretest is going to go through the drive shaping, and there it starts. All right, pretest looks good. It needs 32 millivolts of drive to run this test. I'm going to hit start. All right, so just like my sine test, I'm going to apply graph templates to display graphs as I want them here. So right click on my graph, apply my random control template. Same thing for my drive signal. Apply random drive template. And I'm going to create a new plot with transmissibility again. Not always required for a random test, but it's a nice thing to see. So I'm going to add signals to my new plot and do transmissibility. And this time I'm going to leave my reference as the control signal, which is the average control signal. And I'm going to display the 4 transmissibilities from channel 1, channel 2, channel 7, and channel 8. Okay, so there's my transmissibilities, apply graph template, random transmissibility. And as you can see in my graph templates, I have one more that I'm planning to create. I'm going to create another plot that just has my response plots, all 4 response accelerometers on it. I'm going to right click and click on New Graph, add signals, and I'm going to create a graph that has my reference profile as well as my 4 PSDs from my 4 accelerometers. My left center, and right accelerometers. Now I have a graph template for this too, random response template. And there we go. I've got my profile, the flat random, and then my 4 response accels displayed on the PSD. Displayed on the plot. Okay, so I've still got 45 seconds left in this test. While that's running, I'm just going to point out a couple things about the graphing system here in our software. These tabs that that I've been kind of glossing over, these tabs are actually dockable, so I can actually pull the tab out and full screen it. I can put it onto a second monitor. So if you've got multiple monitors, sometimes it's nice to have a big full screen monitor in your control room. You can do that. The software fully supports that. If I double click on a plot, it makes it full screen. So you can put this onto a second monitor and full screen your plot. Things like that are all natively supported by the software. Okay, so the last thing I'm going to do here, I'm going to rearrange my graphs again so I have them in a nice tiled manner. I like to have the control plot be the biggest one. And I'm going to hit end. Or before I hit end, I'm going to take one more photo to document that the test article made it through the test successfully. So take photo, capture, and save. Test article after vibe. Okay, close. All right, so I'm going to hit end now. So my random test is done. And now the final part of my spec is the post-test sine sweep verification. So this is going to be pretty straightforward. I've already got my sine sweep set up. I'm going to go back to manage tests, open up the sine sweep verification that I've already run once. Just double click on it to open it. It opens up in manage tests, and I'm going to run it one more time. And this is going to be the final verification. Final sine sweep verification. Operator axis. Okay, my stop switch. Start my test. Let the pre-test finish. All right, so in the interest of time here, I know I've only got about 20 minutes left here before I want to finish up, and there's still a lot, the second half of my presentation I want to get to, which it goes over the reporting functionality. So while this test is running, I'm going to let this run, but while it's running, I'm going to start generating my report. And the report's going to start out with my plots from my initial sine sweep. So I'm going to make sure this starts. So this sine sweep is started. I'm going to go back to my managed tests, and I'm going to expand my sine sweep test. And you can see I've got in green my final verification that's running right now. I'm going to double click on the initial sweep, which is going to open up that data in review. So my test is still running here. Just in the interest of time, I'm going to start creating my report for my final sweep, or my final report, which is going to be one report that has data for all 3 of these different tests in this test spec. So our reporting software, we have 2 different flavors of reporting. The first one is our standard reporting, which is called Quick Report. And the second one is our advanced reporting, or custom report. The first thing I'm going to go over is the Quick Report functionality. And then I'm going to generate a report for for this whole vibe test spec, all 3 tests, using Quick Report. Then I'm going to show show you how you can customize a report and generate a completely custom report using the custom report functionality. So I've got my initial sweep open. I'm going to click on the quick report icon here. And this opens the report settings. So I've already got my report settings configured. It saves them, so you don't have to reset them every time. The first tab here in the report settings is the page setup. I'm going to generate the report in landscape mode. I have some page headers. So on each page, I have some variables. So you can see if I double click on each cell in the header, it opens up the variable editor. And these allow you to create test parameters. So all the test parameters I entered, the title, description, my initials, the axis, the description, everything is a variable here, and you can add them to the software or to your report. So I'm going to add, in this test, I have the test name, the customer name, the test article, and the run name that I entered all as a part of the header. I have a logo that's going to go at the top left corner of each page. And then I have footers, which are going to be my operator name and the axis, and then the test date and the date the report was generated. I have page numbers on each page also. So for images, you can, if I had my images selected, my test images and my run images. So the test image is the sine profile and the test article before the sine sweep. Those are the pictures I attached before I started the test. And then the final image is the test article. Oops, got a spelling mistake there. The test article after the sine sweep was completed. So I'm going to add all three of those images there. Each image is going to be as big as it can be, up to approximately 1 page in size. For my plots, I'm going to have the plots that are on the active page, which means the page refers to the tab, this control drive tab. So I've got 3 plots on this page, and all the plots on this page are going to go into my report. Each plot is going to be approximately 1 page in height, in size, and we have an image oversample that basically that'll take the screenshot of the image and make it higher resolution so that it looks good when you zoom in into the report. So you can make really high resolution images that you can zoom in and blow up, and they still look like they're crisp quality plots. Test parameters, I want to have my input channels table, my output channels table describing the shaker setup, and then my setup, measurement setup, my reference profile, and the test schedule. All right, so I'm going to click on report, and it brings up the report preview, and here is my report preview. I've got my plots, 1 plot per page, my control, my drive, and my transmissibility with my resonances peaks labeled. I've got my images that I attach to the test, which are the profile provided by customer, the test article before the test, and the test article after the test, and my test parameters. So I'm going to go and export this test, export this report. You can export it to a variety of formats. Most common are going to be PDF or docx, which is the Microsoft Word format. I'm going to use docx because we support some extra functionalities in the docx format that you'll see in a couple minutes here. So I'm going to call this FlexBeam Quick Report and hit save. Do I want to open this file? Sure, it'll open up in Word, and you can see it's just a normal Word doc where I can actually go in and edit any of the parameters I want to. If you want to make any tweaks to the way that this is formatted, you can do that right in Microsoft Word. So I'll go ahead and save it and close it. So before, the next test was in the test spec was the random test, the random vibe. Before going in and actually and doing the report of the random vibe, I'm going to come back to my sine sweep that I had let run, my final sine sweep verification. I'm going to come in, attach a photo, prove, oops, not attach, take photo, and prove that the test executed successfully with the test article still intact. So test article after sine sweep, and close, and now I'm going to hit end. Okay, so now I've got all three parts of the test profile complete. I've done the report of the first sine sweep. I'm going to open up the operational vibe random test data. So I'm going to double click on that. That opens up my operational vibe random test data in review mode. Now I'm going to go back to quick report, and I'm going to use the same exact settings, but instead of clicking on report, I'm going to click on append. And what append does is it lets me select a report that a docx for a Word file that already exists. I'm going to select the FluxBeam quick report that I just created, and it's going to append this report to that report. So it's done that. Now I'm going to open up the file just to show you. So now my file, I've got the first, this is the initial sine sweep. And if I scroll down, you know, that hasn't changed. It's still got the images and the test data, and boom, here's my random vibe report. Transmissibility and the response and my images and the parameters. Okay, so the final test, the final sine sweep, I'm going to go back to manage tests and open up my final verification. And same thing, quick report. Just to show you a little shortcut here, instead of actually clicking on quick report, you can right click on it, and that automatically opens up the append selector. So it's as if I clicked on quick report and clicked append. So I'm going to select the FluxBeam quick report, and it appended them. So now I've got one report with my sine sweep verification. Zoom out a little bit here. My sine sweep verification, the random report, and then the final sine report starting here. All right, so this is everything I've showed you here. Every reporting functionality I've showed you here is a standard reporting feature. This comes as a standard part of our control software. If you own a 900 series controller or analyzer, you have this functionality. The second part of the reporting demo that I want to get through here in the last 15 minutes is the advanced reporting functionality. So we have the ability to go into Microsoft Word and create templates on your own in Microsoft Word. And then our software can come in, you know, you create a template in Word and you use placeholder text for things like, you know, the test variables like the test name or the test date or the control test levels, and you use placeholder images for things like your plots or the image files that I attached to the test. And then our software can take that template and fill in the blanks, fills in all the placeholders. So to access the custom reporting feature, I opened up my initial run one, the first part of this spec, and I'm going to go to custom report. So the custom report allows me to open up a Word document template, and I'm going to hit edit. And when I hit edit, it opens up the template. So this is my actual Word template that I created beforehand. And this is intended to be done on multiple monitors, but it opens up the template. So I should have this template open on my second screen, and then this dollar variable window opened up on my first screen. So the idea here is I can come in and fill in my template as I want. And if I want a variable, a test variable, for example, if I wanted to print the test name here, right underneath my title, vibration test report, I want the test name. I would come into our software, the dollar variable editor, go to variables, test, and name. And that shows me what I need to enter in my report template for test name. I just hit copy. And in my second screen, I can just paste, and it pastes that into Word. And so I've done that for this entire template, you can see I've got lots of variables: customer name, test article, test name, test description. And I'm using a lot of the advanced Word features like automated table of contents that generates automatically from a sectioned report. So I've got a page for the test overview with the test name, customer name, details, and my operator name, z-axis, date, time. And then I get into my plots. So my plot templates correspond to the pictures that I added, that I attached to the test. So the first picture is the profile definition by the customer. And I just have a placeholder image here. This can be any image. You can take just a black square and paste it in here, and you can resize it to any size you want. The reporting function, our reporting software is going to maintain the size of the image, whatever size. It's what you see is what you get. Whatever size you save it as in the template, our software is going to maintain that size. You can have the image in line with the text as I do now, or you can have it as a floating image that floats in a corner of the screen. Anything like that is possible. And then the way you actually specify which image you want this to correspond to is you right-click on the image and edit alt text. So in the alt text, you can see I have another little code here, just that corresponds to our Signal Calc 900 software. So if I go back to the Signal Calc 900 software, if I go to media, which refers to images, I can say I want image, and I want the first image I attach to the test. So if I double click on test image and say test image number 1, I can highlight that, copy, and just paste that in my alt text. And now when we generate the report, it's going to replace this with the first image that I have attached as part of the test. Similarly for plots, we specify the tab or the page name, control-drive, and then the plot number, which starts with the top left plot and goes down and to the right. So page control-drive, plot number 1, and so on, plot number 3. And I've got more images. I've just got a fully formatted report. This is the kind of report I would want to hand off to a customer, formatted on my terms, so that I could just hand this to Signal Calc 900 and it'll fill in all the blanks. So let me close this report template, and I have that report template selected here. I'm just going to say OK. And it's done creating my report. And let me open it up, and here it is. So you can see my template is still maintained, all of the formatting. I had attached a logo in the corner and the date that got automatically populated. The test name, customer name, and description are all populated. All of the advanced Word features and formatting are maintained. My table of contents is still here. We didn't disrupt any of the test organization that's built into Word, details and execution, and my images. The first image that I had, the placeholder image I had, was the profile definition by the customer name, and you can see we pasted that image with the caption profile provided by customer. And here's my control results, my transmissibility plot, device under test before and after the test, and then the other plots that I had requested in my test template. Then I also had at the bottom of the test template just test run summary and channel summaries that we allow you to access from within the custom report that automatically get filled in as a table in Microsoft Word. So there is the complete custom report for the first test. Now let me go to my second test. I'm going to go back to manage tests and go to my random operational vibe. And I'm going to do the same thing. I'm going to say custom report. I'm going to select the same template, advanced report template, but instead of selecting last time I had default checked here as my output file, I'm going to go ahead and select the file I just created, this advanced report sine sweep for run 1 initial sine sweep. So I'm going to select that and hit OK. And when I hit OK, it's going to ask me, do I want to overwrite or append? And I'm going to say append. And open it up, and here it is. I've got my sine sweep report. Zoom out a little bit here. My sine sweep report, that's still fully populated. And it appended the random report starting here with its own table of contents and such to the, still following the same report template, it appended it to the sine report. Okay, now my third test, the final sine test. Just to complete this fully, I'm going to go back to my, oops, that's not the right test, that's the previous test I ran. My sine sweep final verification. Run number 2 final verification. And custom report. And I'm going to append it. And append. And there I have it, my full custom report, the initial sine sweep verification with a custom report template that I created on my own terms. All my formatting, all my text, my arrangement, my layout, the random report, and the final sine report. Okay, one other thing I didn't quite get to here is I could overlay my my 2 runs. So I could add my first sine sweep run and go to multi-select, and I can actually overlay so it's easy to see if any resonances have shifted. I can just click on overlay and add the transmissibility from my second test for the same signals, and I could generate a report with my transmissibility plots all overlaid, which is typically what the customer would want to see for this type of test spec. So there, I've got all of them, and I can do my custom report with all of my transmissibility plots all overlaid. Oh, there we go. A couple of other pointers here before we get to the final Q&A section. I do have, there are a couple of other items I want to point out about the reporting functionality. So this is for both quick report and for custom report. You can set up automatic reporting at the end of your test. So if you go to the preferences, you can say auto quick report, and that means it'll automatically generate a quick report at the end of the test when the test is done. And you can do the same thing for custom reports. You can automatically generate a custom report at the end of the test. One of the nice features for custom reporting is you can generate multiple reports. So if I have 2 or 3 different templates, say I have one template for users, for my own records, and another template that I use to give to customers, you can have multiple 2 or more templates and custom report templates, and we can go through and automatically generate the report for multiple templates automatically at the end of the test. Thanks for attending. Have a good afternoon or evening.